Okay, now we're gonna kind of put everything together. If we're kind of talking about a sandwich here, we have both pieces of bread. We need the meat on the inside. And what I mean by that is we're gonna start off by taking our system of equations, whether it's two variables or three variables, and putting it into an augmented matrix. Then I need to be able to use my calculator to put it into reduced row echelon form. Then once I have this right here, now I can tell you the answer, the result. But right now, we don't know how to go from here to here yet. So that's where our calculator comes in. Excuse me. Now, before I give you the instructions here, I want you simply to just follow along with me, and then I will give you the instructions here. So example 3 says solve the following systems of equations using matrix or row operations. If the system has no solution, say that it is inconsistent. Okay, now this problem we have already done in lesson 4. This was example 4b. We used elimination to cancel out our y's by multiplying the top by 3 and then multiplying the bottom by that 0.4. Now, whether it is two variables or three variables, you can use this calculator in this row reduced echelon form. So first thing I need to do is write my augmented matrix. So my x is 0.35, my y is 0.4, -3. Here's my bar for my equals, and then 2.4 and 11. So now I need to put this in my calculator to get my row reduced echelon form. So follow along with me, please. Okay, and this is, for the record, a 2x3 matrix. We'll need that when we're putting this in. Okay, so let's turn on the calculator. And first, where I need to go is matrix right here. So I'm going to hit second x to the -1. And I need to come over here to edit. I need to enter in this augmented matrix. So I'm going to go to edit. Now, you have multiple matrices that you can store this into. I am always using matrix A. There is not a reason for any of us really to use B and beyond. If I'm not adding matrices together, if I'm not multiplying matrices together, then I am not storing any other matrices. So I am always going to matrix A. So once I'm over here on edit, it's already on matrix A. I'm just going to hit enter. So the first thing you need to do is put in the dimensions of your matrices. So we have a 2x3. Now, if you happen to get confused and you don't know if it's a 2x3 or a 3x2, if you accidentally put in a 3x2, you can see that these dimensions do not match these dimensions. So if you get confused, it's okay. Just make sure it matches, and then you can continue. So now import and type in all of your matrices here. So when I put in 0.3 and hit enter, it automatically goes to that next space. So 0.4, enter to the next space. And so these should be really fast. Now, just like with your regressions, do not get this wrong because you entered in your matrix wrong. It takes 3 seconds to check these. Check these every time. So we have 0.35, 0.4, -3, 2.4, and 11. I like mine. So now I'm going to get out of here by going to quit. So second mode. Okay, so first thing you have to do is store this matrix into your calculator. So now we need to get to our RREF matrix A command. So we're going to go second x to the -1 to go back into matrix. I'm going to come over here to math, and here's a lot of different things we can do with matrices. You can arrow down if you want to. Here's my RREF command. It's option B. But if you arrow up, it's a lot shorter, so it really doesn't matter how you go about it. Just get to BRREF. So I'm going to hit enter. Now, a really common mistake is that we just hit enter again. And if I hit enter again, I'm going to get an error because my calculator is saying, what am I putting in row reduced echelon form? So once you have your RREF in your calculator, you need to go into matrix one more time. So second x to the -1 and select the matrix we're talking about. Once I have that RREF matrix A in my calculator, hit enter, and here is my matrix in row reduced echelon form. So we got 1, 0, 0, 1. I'm going to put a bar. Notice they don't put a bar here. 4, 3. So now I can answer or solve this question. This one here tells me 1x equals 4, and this one here tells me y equals 3. So this is all my math lab wants, but I would like 4, 3. Which if you look back to lesson 4, hopefully that's the answer we got when we solved that by hand. So I'm going to give you a second. Hopefully you followed along with me. Here are my steps. So pause this video and write those down. And then we will go on to B. Okay, I'm going to move this paper. So if you need more time, you need to pause it. And part B here. So write this in as an augmented matrix. So we've got -2, -2, 4. There's my X column. My Y column is 3, -2, 1. My Z column is 2, 3, 4. And then we have 13, 0, and 11. So let's put this into our calculator and get our row reduced echelon form. Now this one, I put up here R by C. It's always row by column. If you guys ever remember RC Cola, that's what my dad always had. It was disgusting, but that's how I remember row by column. But again, if you can't remember, is it 2 by 3 or 3 by 2? Just play around till you get the right dimensions. But this one here, we have 1, 2, 3 rows by 1, 2, 3, 4 columns. Okay, so let's use our steps that we just wrote down and import this in. So second matrix, we're going to come over here to edit, and I want to just continue always doing matrix A. So we have a 3 by 4. We're going to enter everything in. And notice I'm not needing to clear anything when I'm typing this in. It's typing over. And so I'm just hitting enter and it's going to the next. Like these should be really quick. Before you get out though, check them. -2, -2, 4, 3, -2, 1, 2, 3, 4, 13, 0, 11. So mine looks good. Always check. Don't get it wrong because you entered in a -2 instead of a +2 or whatever the case is. Okay, after we've entered that in, we've checked it, we like it, we're going to get out of there. So let's go to quit, second mode. Now, we can go through these steps again if we want. Here's another reason why I always want to use matrix A though. Once I have this in here recently, if I just arrow up and highlight it and hit enter again, since I have rewrote over my matrix A, all I need to do is re-enter it and it will put the new matrix A that I have stored and now row reduced echelon form. We need to go through these steps here when I haven't done it after a while. But once I've done it, just keep arrowing up, re-highlighting and hit enter and it will change everything for us. So here is Oops. My matrix in row reduced echelon form. And again, notice I don't have that bar, so I'm going to put that in there for myself. And now what does everything read? This first equation is 1x or x equals 0. This does not mean it's no solution. I can have an x value be 0, so that's okay. Next equation is 1y or y equals 3. And then my third equation is 1z or z equals 2. My math lab will just want those values. I want ordered pairs. So this is 0, 3, 2. Let's turn the page. We're going to go over speed in this video as well. Now this one looks a little different here. And it says here, a system with fewer equations than variables has either infinitely many solutions or no solutions. So I can tell just by looking at this that this is one of my special cases. I didn't underline this in the video, but if I go back to where I have my definition of RREF, it does say an augmented matrix representing n equations in variables, meaning my equations and my unknowns are the same. So here I had 2 equations and I had 2 unknowns. I had an unknown x and an unknown y. Here I have 1, 2, 3 equations and I have 3 unknowns. We have x, we have y, we have z. So those should match. Here they don't match because here I have 1, 2, 3 unknowns. I don't know x, I don't know y, and I don't know z, but I only have 1, 2 equations. So they are not the same. So that tells me it's a special case. We're still going to treat it the same way, write it as an augmented matrix. So we have 1, I have no x in this one, so 0. My y is 2, 1. My z is 2, 3. And this equals 4, 6. These are our RREF command. Let's see what we get. So I'm going to go second matrix. I need to edit my new matrix in here. And this one here is a 2 by 4. And again, if you're getting confused on that, if you put that in here as a 4 by 2, you can see that that's not right. So, oops, 2 by 4. And just type this in, hit enter, it goes to the next one, and it overwrites whatever number's there. So 1, enter, 2, enter, 2, enter, 4, enter, keep going. And once we've entered it, we are going to check it because it takes no time and it can make a huge difference. So 1, 0, 2, 1, 2, 3, 4, 6. I like it. Once we've entered it, we checked it, we liked it, we're going to quit. So second mode. You can go through these examples, but since I have my RREF matrix A, you can also just go up, highlight it, hit enter, hit enter. Now, I want to make sure we understand how to do this. I'm going to go through these steps again, just so you can see it a second time around. But after that, I'm just going to always arrow up and hit my matrix A again. But I want to show you these steps again, just in case you need them because you don't have that in your calculator. So what we got to do is we have to go in here to matrix A. I'm going to go over here to math. You can arrow up or down. Up is quicker, and I want to go to option B, RREF, hit enter. That is not complete. If you hit enter, you're going to get an error because it does not know what matrix to put in row reduced echelon form. So before we hit enter, we need to go second matrix one more time and select the matrix I just entered in. I'm always using matrix A, but if you're venturing out, you'll hit whatever matrix and then we can hit enter. So here is my matrix. Okay, and let's write our equations out. This first equation here, if this is my X, my Y, and my Z, my first equation here is 1x or x, no y's, minus 4z equals -8. My second equation here is 0x, 1y, plus 3z equals 6. The easiest one to tell is your no solution. When you have a no solution, you need some kind of equation that gives you a false statement. I'm not really given any false statements here. So it is not no solution. And another way I can tell is because I have two equations, both with a z variable. So that tells me we have infinitely many solutions. Okay, so therefore, we need an x, we need a y, and we need a z. So I'm not going to write these out and solve them the way I did before. Because z is in is in both of those equations, that tells me that z can equal any number. So now to get my x, I only have x in this first equation. To get this x by itself, I would need to add that 4z over. So x equals -8 plus 4z, because those are not like terms. Okay, notice I'm not just picking up that -4z and putting it to the other side. We have to do the opposite. So the opposite of -4z is a positive 4z. So then to get my y, I only have a y in the second equation. So to get y by itself, we would need to move this 3z over, and we would do that by subtracting it. So we'd have 6 minus 3z, because these are not like terms. Now my math lab will want this right here. I want ordered pairs. So -8 plus 4z, that's my x, so comma. Then my y is 6 minus 3z, comma, there's my y coordinate, and then my z is any number. Okay, so now what I have found is an equation here, or a formula, to find any number of these infinitely many solutions.